Testing audio, mic check. Testing audio. 1, 2, 3. Testing audio. Testing audio, mic check. Testing audio. Alright, we sound to be good and we are live. Hello and welcome back, everyone. We are back at it again, trying to conquer physics. Specifically, we're going through another problem of conquering the physics GRE. And so we are looking at sample exam 1, looking at problem 4. You might be wondering, where's problem 3? I glanced over it and my circuits is really weak. So I might actually do a more extensive video going over it, and I don't want to spend too much time on that. So we'll go over this other more conceptual problem, which I will explain where it derives from. And we can see in the description the problem set that reads, a point dipole with dipole moment P is equal to Pz hat is placed at the center of a thin spherical conducting shell of radius r. What is the electric field outside the shell? So if we were to draw this up, we have a spherical conducting shell. And with a little dipole inside of here. And the dipole is written as such. Pz. And so this is radius r. And so normally this thing creates a dipole field that's written as in, if you were to look at the some of the responses on here, which make a lot of sense for a dipole moment. But so I'll write one of them out real quick. So more or less, you'd get something along the lines of this. I'm not saying this is the answer, but you get something along these lines. This is a dependence of the E field. Something along the lines of this. If it was just a normal dipole and you were looking far away from it, this is supposed to be a 3. It's more or less this. But the key bit of this problem is to see we have a spherically conductive shell, which means that the potential that the electrons on this, you can think of the negative or the positive charges on this sphere, can move around. And so one property of conductors is that these electrons will move around in such a way such that the potential is constant here. And so the thing is, this isn't grounded, so the charge will remain the same on this. And so since the charge remains the same, total charge on this sphere, doesn't matter how they rearrange, will be 0. And knowing that we have a dipole in here, it will arrange these charges in such a way that they're not going to be uniform anymore. But the potential will be constant. So the important thing to note is that since the potential field is constant here, that means that if we were to draw a Gaussian sphere over this, we know that there's constant potential here. So the equation for a Gaussian surface, it goes something along the lines of it's proportional to the charge enclosed. So the thing is, we have a dipole in here. Dipoles are neutral. They more or less have a positive charge here and a minus charge here if it's pointing up as shown. So the electric field actually goes something like this in here. Almost how you're used to like the diagrams or schematics for like a little magnet. So when we actually look out here, what is the charge enclosed, right? You go E times 4 pi, you'd say R on the outside. If you were to say this is R to the outside, is equal to charge enclosed. Well, if the charge enclosed is 0, this thing's not grounded. We don't have, at least that we know of, an initial starting charge on the edge of this conductor. So this is 0. And this is a positive number. So when you multiply it both out, you get E is equal to 0 divided by 4 pi r. Oops. So this should actually be the equation of the area of the sphere. And so this will be 0. This is 0. The E field 0. And the equation says, what is the E field outside the shell? So we know it's B, it's 0. So this is a conceptual problem that you just kind of got to know what the equation is. And so, not the equation, you just got to know the concept that conductors rearrange the charge such that you'll have a constant potential, which means that if there was a charge, say, in here, and this was grounded, then we would have a different problem. But since we don't, this is what we have. And so, yeah, I think that's it. So if you answered B, 0, you were correct. If there's any questions on this problem related, let me know and I'll try to elaborate in a further problem session. Until then, y'all take care and have a good night.